Hello dear students, this is Devinder Kaur and you all are welcome to my YouTube channel The Enlightened Room. Today in this video we are going to discuss about the comparison between the ionic compounds and the covalent compounds. So let's get started. So dear students, first of all let us talk about what are ionic compounds and what are covalent compounds. Well, in case of ionic compounds, these are those compounds in which electrons are transferred from one atom to another atom. That means the atom would either lose or gain electrons to the other atom, and then they will form a bond, a chemical bond with each other, and in this process a chemical reaction would occur, forming a compound known as ionic compound, and the bond formed between them is ionic bond. But in case of covalent compound, no transfer of electrons, protons or neutrons occur. Okay, in these compounds, electrons are mutually shared with other atoms, forming a bond, making a chemical reaction and forming a new compound known as covalent compound, and the bond formed by the mutual sharing of electrons is known as covalent bond. So this is a brief description of the definition of ionic compounds and covalent compounds. Now first of all, continuing to the comparison of ionic and covalent compounds, first of all let us talk about the mode of formation. So by the mode of formation, they means how these compounds are formed. So in case of ionic compound, as I told you just now, electrons are transferred from one atom to another atom. So let us take the most common example. We have sodium. Sodium has one electron in its valence shell and chlorine has 7 electrons in its valence shell. So in this process, in this chemical reaction, what would happen? That sodium would donate its 1 electron to chlorine, and in this process a sodium chloride compound is formed, and the bond formed is ionic bond. That means when sodium donated or lost its electron to chlorine, sodium gained the positive charge. Sodium has become sodium ion, and chlorine, as it gains or accepts the electron from sodium, it gains the negative charge and is converted into chloride ion. Okay. That means these compounds are formed only because of the presence of ions. That means if the electrons are transferred from one atom to another atom and ions has been formed, only then the ionic compounds are formed. Okay, but in case of covalent compound, nothing happens like this, right? How covalent compounds are formed? By the mutual sharing of electrons. For example, we have hydrogen. Hydrogen has 1 electron in its valence shell, and these 2 electrons will be shared with each other, forming a bond known as covalent bond, and the bonding is hydrogen bonding here. Similarly, in case of oxygen, double bonding is here. Okay, O2 molecule has formed. CH4, you can take the example. Each and every atom of hydrogen shares the electron with carbon atom, forming covalent bond and forming the covalent compound. So the mode of formation in ionic compounds is because of ions, and in covalent compounds is because of mutual sharing of electrons. Then we have physical state. Well, ionic compounds are most probably solid in state. Whether we talk about sodium chloride is solid in state. Okay, we have common salt at our home, it is solid in state. Magnesium chloride is solid in state. Okay, you can take as much examples, sodium chloride, magnesium chloride. You can take the example of sodium oxide, magnesium oxide, as much examples of ionic compounds you can take. But in case of covalent compounds, there is no proper state of any atom. Okay, since the ionic compounds of all the ionic compounds are solid state. But in case of covalent compounds, there is no restriction that there would be only solid substances would be there, because covalent compounds are found in all the forms: solid form, liquid form, gaseous form. For example, chlorine gas, it is in gaseous form, of course. Bromine is found in liquid form. Okay, hydrogen is also found in gaseous form. Iodine is found in solid form. So they do not have a specific state, they possess in all these states. Okay, now is melting point and boiling point. Well, you all need to remember, all the ionic compounds have high melting and boiling point because they have strong forces of attraction between each other because of the presence of ions. Okay, so they all have high melting and boiling point. But covalent compounds have low melting and boiling point, and the reason behind is the covalent compounds have weak intermolecular forces of attraction. Since the force of attraction is weak, they are intermolecular, that means within the molecules, you can say. So they have low melting and boiling point. Then comes the term of solubility. Now you need to pay attention on this one. Well, the ionic compounds, most of the ionic compounds are polar. You all know that. And all the polar compounds are usually dissolved in polar solutions or polar solvents. And we have the polar solvent is water. Okay. So here we are taking the rule of like dissolves like. That means since all the ionic compounds are polar in nature, they would be dissolved in water. Okay, and as they will be dissolved in water, that means polar is also water, so they possess the solubility like this. But there is an exception which is showed in your screen, that there are certain ionic compounds, for example, silver chloride, barium sulfate, etc., which are actually insoluble in water. Now let's talk about the covalent compounds. In case of covalent compounds are actually non-polar, and they are only soluble in non-polar solvents. For example, alcohol, benzene, toluene, any more non-polar substance you want to discuss here. Okay, so they would dissolve in non-polar solvents, and they would be insoluble in water because water is polar. Also, the ionic compounds are insoluble in non-polar solvents, for example, alcohol, benzene, toluene, whatever the non-polar substances you want to take here. Okay, so here we also taking the rule of like dissolves like. But there is again an exception, and that exception is, my dear students, that ethanol, ethanoic acid, urea and carbohydrates are actually the covalent compounds, yet they are soluble in a polar solvent known as water. Okay, so I hope it is clear to you that they do not dissolve in non-polar solvents, for example, ether, alcohol, benzene, toluene, petrol. Petrol is also non-polar. These are non-polar solvents. Remember this. Okay. Polar substances are not soluble in non-polar. That means ionic ones. And the covalent ones are not polar in water. And there are some exceptions which I have already told you. Then is electrical conductivity. Now by electrical conductivity, what do you mean? That means the compounds that conduct electricity at good rate, right? So in case of ionic compounds, what do you think? They are good conductors of electricity or bad conductors of electricity? Well, of course, they are good conductors of electricity. Now, why they are good conductors of electricity? Well, they are not good conductors of electricity in solid state. When these compounds are molten or dissolved in water, they become the good conductors of electricity. Now, why they become good? The reason behind is that they split up to form ions. For example, sodium chloride is in solid state now. Okay, there are strong forces of attraction between each other. These two would not easily split up on passing the electric current. Okay, so in the solid state, these all would not conduct electricity. When they are in molten state, they would form sodium ion and chloride ion. So when they will form these kind of ions, they have some charge. As they have some charge, they would be able to conduct the electricity. Because charges are responsible for conducting the electricity. You would have already learned it in the electricity chapter. Okay, so in molten state, they conduct electricity. Also, in liquid state or in aqueous state, when they are dissolved in water, they do conduct electricity, because these two has been ionized to form charges. The sodium chloride has been ionized to form charges, and as they have formed charges, they would definitely conduct the electricity. But my dear students, in case of covalent compounds, this does not happen. Covalent compounds all are bad conductors of electricity. Now, why they are bad conductors of electricity? Because they do not possess any ions. If there are no ions, there would be no charge. If there is no charge, there is no conduction of electricity, whether they are solid, liquid or gas. Okay. Now, next one is nature of reactions. That means how do they actually react with each other? Well, in case of ionic compounds, when the ionic compounds react with each other, the reactions are actually instantaneous, very fast, and they speedily give the result. Okay, but in case of covalent compounds, the reactions are actually slow, and they are never going to end. Okay, they are still reacting. The long time has passed, and they are still reacting with each other. Okay, because actually they are sharing. In case of ionic compounds, they have donated their electron. Okay, case closed. End of the discussion. But in case of covalent compounds, they are sharing. Until the electron is present to share, they would keep on continuing to share that electron with each other. So the reaction would keep on going, keep on continuing for a long time. That's why these reactions are considered to be slow, and they are considered that they would never end. Okay, but these are instantaneous and fast. So let us take a look at these reactions. So in case of ionic compounds, we have silver nitrate in aqueous form and sodium chloride again in aqueous form. So when these two would react with each other, I am writing the result down here. When these two would react with each other, there will be silver chloride, which is in solid state, and it deposits at the bottom, forming the white precipitates. Plus one more thing would be formed, which is sodium nitrate, which remains dissolved in that solution, forming the aqueous solution. Okay, but in case of covalent compounds, now this reaction is very quick, very instant. Okay, but in case of covalent compound, we have a reaction, that is methane we have taken in gaseous form, and we have chlorine, which is again in gaseous form. Okay, so what do you think will be formed? CH3Cl can be formed here, which is in gaseous form, plus HCl in gaseous form. But this reaction only occurs during the diffused sunlight. We should have diffused sunlight here. In the presence of this diffused sunlight, this reaction would occur, but it would occur at very slow rate. Okay, so today we have discussed about the difference between the ionic compounds and covalent compounds. In the next video, we are actually starting this chapter at large scale, which is allotropes of carbon, which you all usually found it difficult, but it is very interesting and easy, and we will learn it. So if you haven't subscribed to my channel yet, do subscribe to my channel and click on the bell icon. Thank you for watching.